It feels like every day we see some new headline about AI, right? It's mastering super complex games, it's generating breathtaking art. But what if I told you that behind all that power, there's a really surprising blind spot, a kind of weakness that's, well, pretty fascinating. So today, let's pull back the curtain and take a look at what's really going on under the hood.
So, you've seen the incredible stuff AI can do. It writes code, it makes art. But what if those same super smart systems get completely stumped by the kind of puzzles you probably did as a kid? It's kind of like a modern-day riddle, you know? Like Oedipus facing the Sphinx. The Sphinx posed a riddle. It wasn't about raw power, but about abstract thinking. And that's exactly what we're doing today. We're posing these tricky visual riddles to our most advanced AIs.
Okay, so let's dive right into it. What exactly is this visual blind spot? We're not talking about something simple like recognizing a cat in a photo. This is way deeper. It's about understanding the hidden logic, the rules of the game, just by looking at patterns.
The official term for this is complex graphic reasoning. But honestly, the best way to think about it is like a nonverbal IQ test, but for an AI. You know the ones I'm talking about, right? Where you see a bunch of abstract shapes and you have to figure out the hidden rule, what's rotating, what's changing color, what's the next logical piece in the sequence. That's the skill we're zeroing in on. And look, this difference is absolutely key. On the one hand, you've got simple reasoning. AI is fantastic at this. You ask it, is there a cat in this image? And boom, it tells you. That's just pattern recognition. But complex reasoning, that's a whole different ballgame. It's more like looking at a grid of shapes and thinking, okay, in the first row, the circle moves to the right and the square turns blue. In the second row, the triangle rotates and the star gets bigger. So, based on those rules, what's supposed to happen in this empty space? It's multi-step abstract thinking.
So, to really see how good or not so good AIs are at this, researchers decided to build the ultimate test. Think of it like an Olympic arena, but for an AI's visual reasoning skills. And they made it tough.
They call it ReasonBench, and what's really cool about this is that it's not just a bunch of random computer-generated puzzles. No, this is the real deal. We're talking about over 1,600 questions pulled directly from actual human intelligence tests. You know, things like Mensa entrance exams and the famous Raven's progressive matrices. These are puzzles literally designed to test the limits of human abstract thought.
And this test is deep. It's not just looking at one thing. ReasonBench covers 11, that's right, 11 different core cognitive skills. So it's looking at stuff like positional reasoning, you know, how a shape moves or rotates. Attribute reasoning, like figuring out symmetry. It's even got quantitative stuff, like counting lines or points, and spatial reasoning, like imagining how a flat piece of paper folds up into a cube. It's a total mental workout for anyone, human or not.
All right, so the stage is set. We've got this incredibly tough test designed to push intelligence to its limits. So the big question is, how did the best and brightest AIs, the ones we hear about all the time, actually do? Well, let's just say the results were surprising.
27%. Just let that sink in for a second. That wasn't the average score. That was the score of the best performing AI model they tested. They threw 11 of the most advanced models at this thing, models you would definitely know by name. And the absolute best any of them could do was 27%.
And just to put that number into perspective, look at this. The top AI is down here at 27%. The baseline score for humans taking the exact same test, almost 69%. That gap is just massive. It really shows that this kind of intuitive, abstract reasoning that feels so natural to us is still a huge, huge hurdle for machines.
And if you think that's bad, listen to this. The researchers who ran the study pointed out, and this is a direct quote, that since the questions were multiple choice, just guessing randomly would get you a score of 25%. Think about that. Our most sophisticated AIs are performing just a tiny bit better than pure random guessing. It's a pretty humbling result, to say the least.
But, okay. The story doesn't just end with a failing grade. That's not how science works. Faced with this pretty staggering failure, the researchers didn't just throw their hands up. Instead, they got to work on a solution. They started to develop a new way to train AI, to teach it not just to look at an image, but to actually see and reason about it.
Their solution is this really clever dual optimization strategy. It's basically a two-part plan designed to change how the AI thinks about these puzzles. The goal is to get it to move beyond just matching patterns and start using genuine step-by-step logic.
So here's how they did it. First, there's a technique they call DOT. The important part is what it does. It teaches the AI to show its work, you know, just like your math teacher used to tell you. It forces the model to break the puzzle down piece by piece and analyze each logical step.
Then comes part 2, Reason Tune. The best way to think of this is like targeted practice at the gym. It's a focused workout, drilling the AI on these specific kinds of puzzles to build up its reasoning muscles.
So did it work? Well, to find out, they took a specific open-source AI model and tested it. Before any of this new training, its score was just 21.5%. That's actually worse than guessing randomly. So that's our starting point, our before picture.
And now for the after. After they applied their new two-step training method, that same model's accuracy jumped all the way up to 55%. I mean, that is a huge improvement, more than double its original score. Now, it's still not at that human level of nearly 70%, but it's a massive leap in the right direction. It proves that this kind of abstract reasoning isn't impossible for AI. We just have to learn how to teach it properly.
Okay, so we've seen some pretty wild results, but what does all this mean for you, for the future of AI in general? Why should we care about AI solving abstract puzzles? Let's boil it down to the key takeaways.
So here are the 3 big things to remember from all this. First, and this is a big one, AI is a powerful tool for sure, but it is not a flawless oracle. It has very clear strengths and, as we just saw, some pretty glaring weaknesses. Second takeaway, for an AI, seeing isn't the same as understanding. Just because it can process the pixels in an image doesn't mean it gets the logic behind it. And finally, the most hopeful point, we are actively learning how to teach AI to reason, and developing that skill, that abstract thinking, is absolutely essential for the future of AI.
And that kind of leads to one final big question. We're getting really good at teaching AI to solve our puzzles, but will it ever learn to ask its own questions? Is the real sign of intelligence finding the right answer or asking the right question? And maybe that's the biggest puzzle of them all. I'd love to know what you think about that.